started now on our next lesson. We're going to go ahead and talk about lesson 10-4, day 4. Today we're starting double dot plot. Sounds like the last thing we did, which was double box and whisker or double box plot. But today it's not double box plot, it's a double dot plot because we have double or 1, 2, and they're dots now. So I guess it makes sense, right? And actually, it's very similar to double box plot. It's still using data to compare two different things, and we can still get our central tendencies from this data. Maybe not as easy to read as double box plots, but people like to see the actual numbers sometimes, so that's why they'll use this instead of double box plots. Instead of seeing, clearly seeing the quartiles and clearly seeing the high and the low. Um, Sometimes they want to see where exactly are all the numbers, and that's what double box plot gives us. So let's go ahead and take a look at this this double dot plot, and see if we can answer this question. It says, how would you compare the weather for the two cities? So what this double dot plot right here means is for Springfield, the lowest daily high temperature in Fahrenheit for this time period was right here, and this is 78 degrees. Then the next two were, so we got a 78 degrees, and then for Springfield, we also had this means 79 degrees. And this other dot is another 79. And this dot right here is, yep, you probably guessed it, an 80 degrees. And how many times was it 80 degrees? 2 times. How many times was it 81 degrees? 1, 2, 3. So you get the idea there. So looking at these, if you were to compare these and kind of go into the center like high, you know how we do the median? If you were to find the median, you could actually do it from these dots right here. You could write all the numbers out like I was just doing, or you can literally just use these dots, next one in, next one in, next one in, next one in, and there is my median. My median would be 81 degrees. How about for Lake City? The lowest it got for this time period was right here, 81. The highest, it went all the way up to 87. But the median, if I counted in 1 and 1, 1 and 1, and if I kept counting inward like this until I got to the middle, or if I wrote all those numbers out like I showed you just a second ago and counted into the middle, you would see that the median would be at 84 degrees. So how can we compare the weathers of these two from this double box plot? I can see from looking at these dots where they lie that Lake City is a warmer place. Okay, that's how we use double dot plot to compare two different data sets. So let's take a look at these this double dot plot and see if we can answer this question. Which runner is more likely to run faster? Now I want to point something out here. It looks like, look at how fast Martin was here. He got a 23. That's amazing, right? Well, hopefully some of you looked at this and said, wait a minute, race times in minutes. That means the more you have, that means the slower you were. So the higher we go up, the worse it is, right? We want to finish the race quickly. So the more we go this way for race times, the better you did. So let's not confuse those two, because that's easy to do. I certainly would do that sometimes. So let's go ahead and see who is more likely to be faster. Now, Martin, he is a bullet. He is super fast, but he has days where he's really lazy. So he is clearly faster than Kareem, but he also has days where he doesn't try. So in general, since Kareem is more consistent, will he most likely beat Martin? It's hard to say. So we go to our measures of central tendency. So for example, we can look at the median to decide. If I were to find the median for both these guys, if I were to find, say, the median for Martin, and I'll write this one out this time instead of using a double dot plot. Let's look at the median for Martin. So this dot right here means Martin ran the race in 14 minutes one time. These dots here means he ran it in 15 minutes 3 different times. It took him 16 minutes on 2 different occasions. These dots here means he had 17-minute time mark 3 times. He had an 18, 2 19s, and 2 times it took him 21 minutes, especially lazy day, it took him 23 minutes. So if I were to find the median for these, I can count in, right? 1 and 1, 1 and 1, 1 and 1, until I get to the middle. And if you want to get fancy, you can do a couple. Just make sure you have enough to get fancy, right? And then 1 and 1, and the median, the middle, is 17 minutes. So he usually did 17 minutes or less half of the time, 17 minutes or more half the time also. So how about Kareem? Let me use the double dot plot this time to find the median. Let me cross off this 16, right, in this 20, and another 16, and another 20. And I'll just go 1 and 1, work my way in until I get to the middle. And if I had, look, if I had, like we do here, two numbers in the middle, I'd find the average of these two. But if they're both the same number, the average of 18 and 18 is obviously 18. So I could say, it's hard to say, right? But I could say, you know what? The median for Martin is 17 minutes. The median for Kareem is 18 minutes. So although Martin is lazy at times, because he has a lower median, and lower means better because these are race times, then Martin is usually the faster runner of the two. Take a look at another double dot plot here. We have flight times, and again, this is another situation where more is not better, because the longer the flight time, see your Airjet here, took 8 hours to get there. The longer the flight time, the more miserable you are, right? So the shorter the flight time, the better. So sometimes less is better for these problems. We just have to read the problem and think about it, right? So let's take a look at the first question. I want you guys to pause the video and see if you can find the mean for both airlines. Pause the video now. So if I were to find the mean means average, doesn't it? Average means add them up and divide by how many numbers there are. So we can get our calculator here, okay? And we can start adding these up. I have 2 times, so I got 2 plus 2. I have 3 threes plus 1, 2, 3 threes plus 2 fours, 4 and 4 again, plus 1 5, plus a 7, plus 2 eighths. And how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 numbers, so I divide by 11, and my mean is about 4.5-ish, right? Rounded to about 4.5, okay? So let's check my work there. Yep, the mean is about 4.5 for the first one. Okay, how about cross country? Again, we're going to do the same thing for cross country. Let's see how you guys did. Actually, let me have you check your answer first to see if you're right. So cross country, the mean was 5. Okay, and if you didn't get that, or if you didn't know how to get that, let's see how to do that right now. I'm going to take these numbers over here and add them all up. I have a 3 and a 3. 1 3, 2 3s, and 2 4s. 1 4, 2 4s, and 3 5s. 1, 2, 3. 2 6s. 1, 2, and 2 7s. 1, 2. Total 55. Divide by how many numbers there are. 1 2 3 4 5 6 7 8 9 10 11 numbers. Divided by 11, and we get a mean or an average of 5. So you guys see how we did that. That's really review, isn't it? Finding the mean just means add all these numbers up and divide by however many numbers there are. Calculator's okay. The other thing we learned new today is, where do we get the numbers from? This dot means 2. This means 2. This means 3. And that's all we learned new so far. So let's take a look at the next part. We're going to find the median flight for both airlines. And this is where we write them in order from least to greatest and work our way into the middle. And if there's two numbers in the middle, we take the average of those two. But since they're already in order for us, we could even use a double dot plot. So for Airjet, we can go, that's the smallest, that's the biggest, that's the next smallest, next biggest. Well, they're tied, but just work my way in, right? 1 and 1, 1 and 1, and the number in the middle was 4. So I see that the median for Airjet Express, the median is 4. How about the median for cross-country airlines? So let me do it the other way this time. Let me not use a double dot plot. Let me write the numbers out, because some of you might like that better. So this is a 3, right? I'll write it down. Cross it out as I go. When I'm writing it down, so that I don't miss any. I have 3 5s. And this way really doesn't take that long because they're all in order, aren't they? 2 6s and 2 7s. Look, that didn't take long at all, did it? So we'll count our way in. We'll go cross it off. We're trying to get to the middle. Hopefully there's a number in the middle. If there isn't, we'll take the average of the two, but there is. So I see that the median for the other airline was 5 for cross-country airlines. Next question. So which airline has the shorter flights? Well, you can kind of take a look at it. Remember, this way is better. Those are shorter, right? So it looks like these guys have more flights that are this way than these guys. And if that's not a very sophisticated sounding argument, then we can go to the central tendencies, right? So what was it? Airjet? Yeah, Airjet Express and cross country. Airjet has a smaller average and it has a smaller median. So certainly you can argue that Airjet has shorter flights. This is how we use double dot plots and box and whisker double dot double box and whisker or double box plots both to compare data. So let's take a look at our last question now. It says find the interquartile range for cross-country airlines. So now for this one here, I wouldn't use the graph here for this one. I would write this one out. You can use a graph if it works for you, great. But so I would write it out. I got 2 3s, 2 4s, 3 5s, 2 6s, and 2 7s. So the median is going to be in the middle, right? 1, 2, 3. I know we already did this, but I'm just pretending that we didn't. Going in the middle, and my middle is 5. So my first quartile means I'm going to take this half and go in the middle again. So I go 1 and 1, 2 and 2, and the middle of this half is 4. This is my first quartile. To get my second quartile is the median. To get my third quartile, I got to take this half or go to the right of the median and find the middle again. 1, 1, 1, 1. The middle is 6. So in a box and whisker, right? My box would go here like this. This would be my box. Median's in the middle. First quartile, third quartile. Whiskers go like this. There's my box and whisker on there. Okay. Now let me get this mess out of here. And see what's the interquartile range. Well, I take my first quartile, which is 4, my third quartile, which is 6, subtract those two, and this is how we get our interquartile range. It's the same as regular range. We're subtracting low and high, but I'm subtracting these lows and highs and not the extreme lows and highs. Okay? All right, let's move on to the next problem. So we have a double dot plot here. It shows the daily temperatures in January for city A and city B. So let's go ahead and check which of these are true and which are false. So it says, is it true that the medians are the same? Well, let's find the medians for both. Let's go ahead and use the double dot plot this time. So the median, I'm going to count my way in the middle, right? Here, here. And if it was a box and whisker or a double box plot, it would be pretty quick to see, right? And these two are in the middle. The average of those two has to be, they're the same number. So the average has to be 35. Okay. So the median for city A has a median of 35. So let's check the median for city B. City B, we have 1 and 1, 1 and 1. And you know what? Let's try it another way. If you got that way, great. But some of you like to take shortcuts. Let's try another way for some of you. Let's just count how many there are. There's 1, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 numbers, right? If there's 14 numbers and I cut it in half, then that means that one half has to be 1, 2, 3, 4, 5, 6, 7. This is half the numbers. And the other half, the other half has to be 1, 2, 3, 4, 5, 6, 7. This is the other half. So the median or middle has to be right about there. So it has to be 36. So the median for this one is 36. Let's use that method and check city A and see if we get the same thing, okay? let's find the median over here by counting all the numbers first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So half of 14 is 7, so count the first 7. 1, 2, 3, 4, 5, 6, 7. This is the first half. This is the second half. In the middle is 35. So if you like that method, you guys can go ahead and use that. Now, are the medians the same? Answer, no, they're not the same. There's a difference of 1 between those two. How about the interquartile range? Well, remember, interquartile range means find the median of the two halves and subtract those two. So let's go up here to city A. This is 1/2, right? There's 1, 2, 3, 4, 5, 6, 7. So if I count my way in, it's going to be 3 on each side, right? And the 7th is right there. That's going to be in the middle. Okay, let me do it on this side. Let me do it differently if that didn't make sense to you. Let me do it differently. I'll count 1 and 1. I'm working my way in. 1 and 1. 1 and 1. The middle is right there. So the first quartile is 33 for city A. And the third quartile, because remember the second is the median, right? This is the second quartile. And the third quartile is this dot right here, which is 36. That means that the interquartile range, which is like the regular range, subtract big and small, but of these two numbers we subtract, not the smallest and the biggest for the whole thing, and I get an interquartile range of 3. Let's try city B. I have 7 here, so the middle, I'm going to have 3 on each side, and the middle will be this one right here. The first quartile is 35. Second quartile is the median. Third quartile, again, 2, 4, 6, 7. So half is 3 and 3. And then the middle of those 3 and 3 would be 37. And I see that the interquartile range is 3 for city A and 2 for city B. So the interquartile ranges are the same? No, that's not true either. They're not the same. Temperatures for city B are more consistent. Now let's take a look at that. Temperatures for city B are more consistent. Let me see here. If I look at this, consistency means symmetry. Symmetry means it's going to look like this. It's going to be kind of be like a pyramid shape. It's going to be the same on both sides. This is not symmetrical. Like some scattered. So symmetrical will kind of look like this on a double dot plot, right? In the double box plot, that means that these quartiles are all kind of the same distance. This is the same as this, right? And the same as this and the same as this. But for here, we just want it to kind of all look the same. We don't want it to be like a bunch here, some down there, like it looks up here. So I would say the temperatures for city B are more consistent. Absolutely, that one's true. These two are false. Let's take a look at our answer, see if I got it wrong. And yep, false, false, true. We are okay. So let's go ahead and start our review section right now. I want you guys to pause the video and solve this equation. All right, we're solving a two-step equation. I have a variable on top of a fraction here. I know that I need to work farthest away from the variable first, so I will move the 7, not the 8 first. The opposite of positive 7 is to subtract 7 from both sides. That will get rid of that. That's the process of getting z by itself. When z is by itself, I know what z is. How do I get rid of the 8 when it's on the bottom of a fraction and the variable's on top? Well, this means division. The opposite of division is multiplication. So I multiply both sides by 8. And those 8's cross out. And I should get an answer of 88. By solving this, I found the missing number. So what number divided by 8 plus 7 is 17? Well, 88 divided by 8, which is 11, plus 7 is 18. That's what we figured out by solving. Pause the video, solve this two-step equation. Our good friends fractions are coming back to visit us, and you guys are going to be so ready for 8th grade next year. It's not even going to be funny. Now, just like the last problem, but we have fractions, so we're going to make everything a fraction, right? 2 1/4 means 4 times 2 is 8, plus 1 is 9. That's the same as 9/4, same number. 1 1/4 is the same as 5/4. And now I'm going to subtract these two, and thankfully they're already the same. They have the same denominator, same bottom number, so they're already the same size pieces. I put my negative up top when I'm dealing with fractions. So I can just add the numerators, the top numbers. I have 5 positives, 4 negatives. Opposite team subtracts. There are more negatives than positives. So I have negative 4/4, which can simplify just negative 1, can it? So I have 1/4 times what equals negative 1. Now, when there's a fraction in front of our variable or fractional coefficient, we can get rid of it by multiplying by the reciprocal of that, or using what's called a multiplicative inverse. Multiplicative inverse is something that multiplies to a number to make it become 1, and we want that because 1 times n is just n. All right, and our answer is negative 4. I'll show you that here, negative 4. So I want you guys to go ahead and pause the video and simplify this algebraic expression. So the way we simplify is we distribute and combine like terms, but I want to go ahead and do the rule for subtraction anytime I can. And inside the parentheses, I see that it's already addition, so I'm not going to draw 2 sticks. But over here, I do have a subtraction problem, so I'll draw 2 sticks. 1, 2, or add the opposite. So now I'm going to distribute. Since that negative 6 is next to those parentheses, negative 6 times negative 8 is positive 48. And, oh, don't forget the v, right? See, you don't want to forget the v like I just did. It's negative 48. There's a v next to it, so negative 48v. And negative 5 times, negative 6 times positive 5 is going to be negative 30. And don't forget that negative 7 over there. It's a negative. So I'm going to combine like terms. I add constants to constants. I don't add constants to v's. That's part of the v family. So these guys are on opposite teams. Oh, actually, no, that's a negative 30. They're on the same team, aren't they? When they're on the same team, we add those together and we ask who has more. Since they're all negatives, obviously negatives have more. And another way we can write this answer, plus negative 37, is just subtract 37, right? Kind of weird that we did rule for subtraction just to undo it later. This is really more for next year. When these get longer, it'll be helpful to have that skill. Okay, so there's our answer. I want you guys to pause the video and try the next problem. So they say in this Eastern Caribbean island that $7 is 19 of their dollars, right? So find how many of their dollars would it be for 21 US dollars. So I'll put US dollars on top and their dollars on the bottom. Since I don't know how many for 21, I can cross multiply, and this is totally fine if you guys break out your calculator right now. And we can just do 19 times 21, and we get 399 here. Then divide by the coefficient. We already have 399 in our calculator, so we'll just hit division, divide by 7, and we get 57. But 57 what? 57 Eastern Caribbean dollars, or is it Caribbean? All right, pause the video, answer this question. Anytime we have percent, we know we can use percent proportion. It goes is over of equals percent over 100%. We could always use that. So what percent, we don't know the percent, so I'll put X this time, over 100. What percent of 12 minutes is 3? So the is 3 and the of is 12. 3 is not going on top because it's smaller. 3 goes on top because it's the is. It is the is. So I got 3 times 100 is 300 equals 12 times x, which is 12x. And divide by the coefficient. Break out the calculator. Do some calculating. We go 300 division 12, and we get 25 of 25. What? Well, it's not percent. Oh, yeah, it is. We're missing percent, so it should be 25%. Now, if you use another method, for example, if you said 3 out of 12 and you just divided, you went 3 divided by 12 like this, 3 division 12, and you didn't use percent proportion, you could still get the answer, but you'd have to remember to convert decimal to percent by moving the decimal 2 times. When you use percent proportion, no converting necessary. How do you find the area of a circle? You guys go ahead and pause the video now and do that. So the area of a circle is, well, if I round pi to about 3.14, it's about pi r squared. Going to grab a calculator. The only way we can get this wrong, I think, is if we don't do our 7.6 times 7.6 first. Other than that, it's a matter of pushing buttons. And some of you are pretty good at pushing buttons, so we should have done that well. Hopefully you got an average or answer there of about 181 and 5/10 centimeters squared. Remember, squared for area, cubed for volume. If you were very close but a little bit bigger, that means you pushed your pi button on your calculator. You're still right. Go ahead and pause the video and find the volume. And for our last problem, the volume of prisms is the area of the base times the height, not little b, capital B. And for a rectangular prism, well, this base is a rectangle, and the area of a rectangle is length times width. So all boxes, volume is length times width times height. So we have 9 times 5 times 8. Grab our calculator and pound this guy out here. We got 9 times 5 times 8. 360. 360 what, you guys? 360 meters cubed. All right, that's it for today. We'll see you guys soon. Hope you guys doing well.